lest we forget, I'm using free software, so I'm not really editing, and I only get 10 minutes. So that you just saw was part 1, and now we're back for part 2. What do we do with, not cloud, but what do we do with DNA fingerprinting? So we saw a real example from a crime scene, and you can be the judge of whether you think that, whatever you think. Okay, I'm just showing you the DNA evidence. So now, let's head back to TV land and talk about the Maury Show. It's not really the Maury Show, but if you feel like clicking on this link or finding it, then you can watch that as your little preview, and then we'll get Maury on and be like, the results are in. Let me get my results folder. The results are in. Okay, when it comes to 2-year-old John, are you the father? We're gonna find out. So here is the mother's DNA. And here we have the child's DNA. Now, if you look, the mom and child have, like, half the DNA of the child is in common with the mother. Okay, so I'm just pointing with my mouse the ones that match up. So if you need to go back and look at it, look at it. Like, you see these two at the bottom match. These two here match. Okay, so what about the ones that don't match, like this one? Well, that one had to come from the father. So you will see that half of the DNA of the child is going to match with the father, the other half is going to match with the mother. If there's, let's just take a look. So we've got father 1 and father 2. So we're going to count how many things they have in common with the child. So let's see. Father potential 1 has 1. And then, I don't think that matches. We could maybe call it 1.5 in case my eyes are not the greatest. Okay, what about father 2? It has 1, 2, 3, 4, 5 in common. So I'll let you pause, hit pause, and figure out who you think the father is, 1 or 2. It's 2. That one has more in common with the child than father 1. So that must be the father. Okay. The other thing that's really cool is we can use DNA tests to show evolutionary relationships. So, for example, we have species 1 and 2. They share 3 of these sections of DNA in common. That shows that they're fairly closely related. What about 3 and 4? Are 3 and 4 closely related to 1 and 2? They don't seem to share anything in common with 1 and 2, so maybe they're not very closely related. And what about 3 and 4 together? Well, they share quite a bit in common, so they must be very closely related. And let's look at species 5. Well, species 5 has one thing there and one thing with them. They seem kind of doing their own thing, so maybe they're not very closely related to 1, 2, 3, 4, or 5. So then what scientists would do using this DNA information, they would maybe be able to change how they classify organisms. We talked a while ago about the classification system: kingdom, phylum, class, order, family, genus, species. Maybe originally we had 3 and 4 in the same family, but now looking at this DNA test, we're like, maybe they need to be in the same genus. They seem to be very closely related. So that can change how we classify them in the 7 different classification groups. And then from that, we can use that to draw a phylogenetic tree, a family tree of them. So let's take a look at that, how that might look. Remember, where they join together, that shows the most recent common ancestor. The closer the little v is, that means the more closely they are related, or the more recently they shared a common ancestor. So because 1 and 2 are not really close to 3 and 4, they branch off a long time ago. This part of the V shows, hey, this is the last time 1, 2, 3, and 4 shared a common ancestor. It's kind of a long time ago. And 5 is really on its own. So the last time 1, 2, 3, and 4 shared a common ancestor with 5 was way down here. That could be 400 million years ago. Okay, so let's see what example animals these could be. So we could have a turtle and a snake. Those are both reptiles. Here we have a rat and a squirrel. Those are both rodents. They're more closely related to each other than a turtle and a snake, but they're definitely more closely related to each other than they are to a reptile. Then here's a fruit fly. Not really close to any of them. It's an arthropod. Okay, so the next time that we talk, or the next time I show you some stuff, it's going to be about GMOs. That stands for genetically modified organisms. So that will be the next couple videos that I make and send to you guys. But for now, that's it, and I hope that helps. Bye.